Alright, so day whatever we're on, day 3, unit 2, day 3. More power rule for derivatives problems, meanings of derivatives. So there's again, no new concepts today. So I don't need to say, hey, here's the new derivative rules. We'll do some of that tomorrow. But today, no new rules, just more practice. Find the slope of the line tangent to the curve. So what's that asking for? Slope of the line tangent to the curve. That's the derivative. Again, it feels like there's 8 ways to ask for a derivative. There's probably 4 or 5. And we just want to hit all of those to make sure you're good with them. I probably want to do some algebra first here to rewrite these things. So let's pick on some people to check our algebra skills here. If I have the 4th root of x cubed, Seth, how could I rewrite that as just a power? What would the power be? 3/4. Good. Adding 6 over x to the 5th, how could I rewrite like over x to the 5th as x to a power? 6x to the negative 5th. And then lastly, Aslan, how about that? You get the hard one here. The 7th root of x squared in the bottom, how could I rewrite that as x to a power? Negative 2 over 7. So a whole bunch of algebra, and then a little bit of calculus. Now the power rule. So let's see, 22x to the 10th. 3/4 of 12, that would be 9. And then 3/4 minus 1. Like these are the mistakes that people make on the test. Like they know the power rule, but then they do 3/4 minus 1 and mess something up. Negative 1/4. Minus 30. Here's another one to mess up. From negative 5, if you subtract 1, negative 6. You want to guess what the common wrong answer is? Negative 4. Right? Because 1 less than 5 is 4. Well, yes, but that's negative 5, so let's go down to negative 6. 14 times 2/7 would be 4. 14 over 7 is 2, times 2 is 4. And then negative 2/7 minus 1, negative 9/7. So like a big chunk of this test is, I know the calculus rule, but can I subtract fractions and integers and multiply fractions? What do we want to do first on number 2? Move that x out, or divide by x, or move it to the top, rewrite it, however you want to phrase that. Algebra step first. So let's pick on 3 people to divide by x. So McKenna, 6x cubed divided by x? 6x squared. It's algebra review day. Autumn, 8x over x?
8.
Minus 8. Jameson, you get a little bit of a tricky one, I guess.
3x to the negative 1.
Yep, 3x to the negative 1. Again, be careful. The other common mistake is students get there and they're like, whew, got the algebra right. Let's move on to the next problem. Wait a minute, you haven't answered the question yet. Slope of the line tangent to the graph is f prime. So 12x. Oh, what's the derivative of minus 8? 0. Minus 3x to the negative 2. Are we done yet? Got to plug in 1/3. When x is 1/3. So f prime of 1/3. So 12 times 1/3 minus 3. Oh, this is going to be weird looking maybe. 1/3 to the negative 2. So 12 times 1/3 is 4. I got that. What's 1/3 to the negative 2? 9, right? You flip it and square it. So the negative flips the 1/3 back to 3, and then squared you get 9. And then, well, actually, the previous step would have been a safe stop for a free response. But multiple choice is probably going to simplify that all the way down to negative 23. So yeah, definitely use those safe stops. A bunch of you did on the test, and it's great. Like, do it. Number 3. Okay, starts the same way. Let's divide by x squared. So 5 minus 4x to the negative 1 minus 2x to the negative 2. Okay, but what's a horizontal tangent line? Okay, show me with your arm what a horizontal tangent line looks like. Let's make sure we're, okay. Some people doing this. Oh, a double-armed horizontal tangent line. What's the slope of a horizontal tangent line? 0. So if I want to know where this thing has a slope of 0, let's take a derivative, because that would tell me slope, and then we'll set it equal to 0. So dy dx would be 4x to the negative 2 plus 4x to the negative 3. That would be the slope, and I want that to equal 0. Let's write this as fractions. That might be a better option there. Couple options. What would you do to solve that for x? Seeing at least 3 different things we could do here. What would you do? How would you solve that for x? No ideas? I think I would multiply, when you say multiply them both by x cubed. Like this. That's okay. I like that idea. Just make sure you multiply both sides by x cubed. Although it kind of doesn't matter on this one because it turns out to be 0. But I like that because then your fractions are gone. And you've got 4x plus 4 equals 0. So that's probably the best first step, because now we got a super easy problem to deal with. So x equals negative 1. So that means whatever this thing looks like, when x is negative 1, there's a horizontal tangent line. This is a commonly asked problem because horizontal tangent lines have multiple meanings later. So that's why we throw that in there. Let's skip number 4. It's pretty similar. When is the thing equal to 2? So you would just set your derivative equal to 2. I'm not worried about that. That's similar to what we just did. But number 5 down there, write an equation of the tangent line to the graph when x is 3. Okay, let's go back to equations of lines. What format of the equations of lines do you remember? Yep, that's the one that people remember most of all. Y equals mx plus b. Let's go, yes, except we're not going to use that one. The other one that we use is called point slope form. And you don't use it much in your earlier classes, but we use it a ton in calculus. Do you remember what it looks like? We use that one a bunch because in order to use it, you need a point and a slope. So whenever it asks you for a tangent line, you should almost immediately be thinking, all right, I need a point and a slope, and once I get that, then I'll be fine to write the point slope form of the line. Okay, so I need a point. Well, it gave me x equals 3, so I guess I'm halfway there. How would I find the y value? Plug it in. So g of 3, 2 times 9 minus 4 times 3 plus 5. 18 minus 12 plus 5, 6 plus 5 is 11. So that's like algebra 1 part of the problem. Find the given x, find y. Plug it in. How am I going to find the slope of the tangent line? Slope and derivative we use almost interchangeably. So let's take a derivative. 4x minus 4. I use them to give us an easy one. But then the derivative at 3 means plug in 3. So 12 minus 4 is 8. So got my point, got my slope. Y minus 11 equals 8 times x minus 3. Another super common calculus question is write the equation of the tangent line. You're going to do that a lot. No wonder that's spaced wrong. Look at all that empty space at the top of the next page. Why don't you try number 6? Write the equation of a tangent line. So you need a point and a slope. So there's a couple steps there. Why don't you try number 6? So again, we plug in 16 into f to get the point. 16 comma 9. No big deal. Derivative, kind of ugly, but not terrible. And then when we plug in 16, things get a little bit more ugly. Slope is negative 9/64. But we're almost done, and we don't have to do anything with negative 9/64, so it's not that bad. Y minus 9, negative 9/64 times x minus 16. Equation of a tangent line. Number 7. Polynomial has a relative extremum at the point when... okay, think back. Do you remember what x cubed looks like, roughly? It's like, and it's positive, so it looks something like that. A relative extremum, that would be like a peak or a valley. So again, I'm talking like big picture concepts right now. We're not worried about this particular cubic. So a peak or a valley would look like right there or right there. Can you tell by looking what the slope is at the peak or a valley? What's the slope right there? This goes back to what we did with these things. So they're both horizontal tangent lines. So slope equals 0. So we'll talk more about this later, but if the slope equals 0, then, let's be careful here, maybe we have a relative extrema. So let's take a derivative, set it equal to 0, and that will tell us possible extrema. X squared plus 4x. So that was kind. That's an easy one to solve, hopefully. Set it equal to 0. Factor out a 4 and an x. So x equals 0 and x equals negative 1/3. So those are places where the slope is 0. And if the slope is 0, we don't know yet if which one's, a max or a min. that's for later, but we've got the idea of set the slope equal to 0 to find possible maximum lengths. Okay, let's see. Slope equals 0, slope is negative, slope is positive. Why don't you try 8 through 12, and then we'll pull some popsicle sticks for those. Okay, so there's those answers. Any questions on those? Again, that's nothing new, just applying what you hopefully already know. Derivative means slope, tangent lines, horizontal tangent lines. Not a whole lot new today, just more practice of the same kind of things. All right, today's assignment then is worksheet 3. Please keep up with this stuff, otherwise it starts to snowball. Tomorrow, or I guess Thursday, we do something new. Actually, we do a couple of new things. So you definitely want to make sure you're okay with all the things up through this, so that when we do new stuff on Thursday, we'll be using this stuff. Hopefully you'll be okay.